What if you could see the invisible engine that powers the most destructive storms on the planet? An engine that spins faster than a tornado and reaches higher than Mount Everest. Picture a storm so powerful it can reshape landscapes. A storm that doesn't just move across the sky, it dominates it. This isn't your typical thunderstorm. This is a supercell, and at its heart lies one of nature's most terrifying creations. A rotating updraft that acts like an atmospheric vortex. Most thunderstorms come and go within an hour. But supercells can rage for hours, traveling hundreds of miles while spawning tornadoes, dropping hailstones the size of baseballs, and unleashing winds that can strip the ground bare. What makes them so different? What gives them such relentless power? The answer lies in that spinning core, a phenomenon so complex that meteorologists are still unraveling its secrets. To understand how supercells form, we need to start with something simple. Rising air. In any thunderstorm, warm, moist air rises upward, creating what's called an updraft. But in a supercell, this updraft doesn't just go straight up, it begins to rotate. And that rotation changes everything. Think of it like this. Imagine you're stirring a pot of water. As you move the spoon in a circle, the water starts spinning faster and faster, forming a vortex. Now imagine that happening across miles of sky, with winds powerful enough to lift entire houses. That's essentially what's happening inside a supercell's updraft, but on a scale so massive it defies belief. So how does this rotation begin? It starts with wind shear, when wind speed or direction changes with height. Near the ground, winds might be blowing from the south. Higher up, they're blowing from the west. This creates a horizontal tube of spinning air, like a rolling pin made of wind. When a thunderstorm's updraft hits this tube, it tilts it vertically. Suddenly, that horizontal spin becomes a vertical one, a massive, rotating column of air rising through the storm. This rotating updraft, called a mesocyclone, becomes the storm's beating heart. It's what separates supercells from ordinary thunderstorms. While regular storms eventually choke on their own rain-cooled air, the mesocyclone in a supercell actually helps the storm breathe. It keeps warm, moist air flowing into the storm while pushing cooler, stable air away. This creates a self-sustaining system that can maintain its structure for hours. But the real magic and danger happens inside this rotating core. As air spirals upward, it accelerates, much like a figure skater pulling their arms in to spin faster. This rotation creates an area of lower pressure at the center of the updraft. That low pressure acts like a vacuum, pulling even more warm, moist air into the storm. It's a feedback loop of incredible power. More rotation creates lower pressure, which pulls in more fuel, which strengthens the rotation further. This is why supercells can produce such extreme weather. That intense rotation is what creates the massive hailstones, some as large as grapefruits. As raindrops get caught in the updraft's powerful winds, they're carried upward into extremely cold regions of the storm where they freeze. But instead of falling down, they get recycled through the updraft multiple times, collecting more layers of ice until they become too heavy for the winds to support. Then they come crashing down with devastating force. And of course, there are the tornadoes. Not every supercell produces a tornado, but when conditions are right, that rotating updraft can tighten and extend downward, creating one of nature's most violent phenomena. The mesocyclone essentially gives birth to the tornado. acting as the parent circulation that the tornado draws its rotation from. What's truly remarkable is how these storms can maintain their structure while moving. Unlike regular storms that typically move with the wind, supercells often move to the right of the prevailing winds. This rightward motion helps them stay in the most favorable environment for continued development. They essentially steer themselves into areas with the best combination of warm, moist air and wind shear, the very ingredients that keep them alive. The lifespan of a supercell is a delicate dance between destruction and creation. These storms are constantly rebuilding themselves, with new updrafts forming as old ones collapse. The rotation helps organize this process, creating a storm that's both incredibly stable and incredibly violent. Some supercells have been known to travel over 300 miles while maintaining their intensity, enough to cross multiple states without weakening. As terrifying as supercells are, they're also beautiful in their complexity. The classic supercell has a distinctive appearance, with a flat, anvil-shaped top spreading out for miles, and a lowered area called a wall cloud where rotation is most intense. Storm chasers recognize these features from miles away, knowing they're witnessing one of nature's most powerful displays. What we are learning from studying these storms is changing how we understand severe weather. Modern Doppler radar can now peer inside these rotating updrafts, revealing details about wind speeds and rotation that were once invisible. This has dramatically improved tornado warnings, giving people precious extra minutes to seek shelter. But despite all our advances, supercells remain somewhat mysterious. We still don't fully understand why some rotating updrafts produce tornadoes while others don't. We're still learning how exactly hail forms within these storms. Each new supercell we study reveals another piece of the puzzle. The rotating updraft of a supercell represents one of the most efficient energy conversion systems in nature. It takes the simple ingredients of warm, moist air and wind shear, and transforms them into a self-sustaining engine of incredible power. Understanding how this engine works isn't just about satisfying scientific curiosity. It's about saving lives by better predicting when and where these storms will turn deadly. Perhaps the most humbling realization is that for all our technology and knowledge, we still can't stop these storms from forming. We can only watch, learn, and warn. The rotating updraft reminds us that nature possesses forces far beyond human control, forces that command both our respect and our awe. What weather phenomenon would you like us to explore next? Share your ideas in the comments below, and make sure to subscribe to Nature Unlocked to uncover more of Earth's incredible secrets.